just want me to start with the ones that
Yeah.
you've
Yeah.
missed?
Mm-hmm.
Okay. All right. Do you want me to enter the answers as we go?
Sure.
Okay. Um, some of these I think I can just talk through verbally. Did you try putting 5 into both of these functions?
No.
Okay, so when you do that, you get the same value out.
Okay.
So that's why it does not exist.
Okay. What does that mean? Like why?
It would be if they evaluated to different numbers. Like let's say the top one evaluated to 0 and the bottom one evaluated to 1. They have different values. Does that help?
Yes. Sorry, I'm just trying to find my calculator.
Okay.
I got it out. Okay, that's nothing.
Okay, so go to 16.
So you plug in the numbers for.
Yeah, the way though I have to do this is I have to stop sharing the screen and go to the workspace if you want to see this worked out, or I can talk through them verbally.
Yeah.
What
I mean,
what would you
I'm
prefer?
fine. I mean, we can. It depends. I think like we can. This one we can do, and then we'll just go by if we want to talk through them.
Okay, so you try at 4. Like you try what's 4 minus 4? Well, it's 0, and then you try 4 plus 4. Well, that's 8. Those are different. Okay, they're different. Great. So let's try that now. It's 6. So 6 plus 4, which is 10, and then put 6 into here. So it's 6 squared minus 26, which is also 10. So since these are the same, it's not discontinuous. But here it is. If they're different values, it's discontinuous. So it's discontinuous at 4. Now the singular point is something slightly different. You can always know that it's just the other x value, but I don't know if that's easy enough. I don't know if that's worth remembering. But I'd have to give you more information to explain why that is.
I don't know. I mean, I don't even know if I'd get one of these.
I mean, from the list you sent me the other night, no,
Yeah.
you
Yeah.
wouldn't.
Okay.
But 6 and then 4. I can go back and forth. It's not a problem. It's just tiny bit of slow down each time. Let me go back up to the top.
Yeah. If you just
And
easier.
27 look like the next one.
Yeah.
So this one you have to take a derivative.
Okay.
Okay. I'm sorry. Yeah, you want to take the derivative and set it equal to 0.
Oh, okay, got it.
So the derivative is it's the derivative. I'll just type in here. It's minus 14x minus 6.
So
And you set that equal to 0 and solve for x. So it ends up being
-3/7.
yes.
Okay. And then we were learned about El Hospital's rule, and then he said it wasn't on any of our exams, and he said it wouldn't be on the final either. So that's, I mean, I'm not, but
Okay.
obviously I can do it. But
So should we skip 28? Is that what you're saying?
yeah, I mean, I can email him and just clarify. So yeah, that's fine. And if it is, we can go over it tomorrow.
Okay. Great. So
I think
32.
Yeah, these
Okay.
ones I always have. This one I have no idea how to do. Like past the 2 that I got right.
Okay. You could get something like this.
Yeah,
The marginal
I've
cost.
had that on the test before.
Okay. The cost is increasing at a rate of, so it's the number you got from here.
Okay.
The exact cost of producing the 101st teddy bear is so the 101st the 101st teddy bear is you have to put 101 into this function up here.
Okay.
And then you have to subtract 100.
Okay. So why do you put it into that and not the derivative one?
The derivative gives you the additional cost of the second teddy bear, but it's a derivative because this says the exact cost, not an approximation. The derivative gives you an approximation at that point.
Okay, so I got, wait, then you subtract what you plug in for 100?
Yeah, you have to do it for 101 and then for 100.
Um, 42.99.
Okay, I don't know if that's correct, but
Yeah.
we're going to go with it. Thus, there's a difference of,
Hmm.
I think it's 42.99. Let me check those.
Yeah.
I'm sorry, I have so many things open.
Do you think part of it is if I'm on it too? Should I exit out?
No, it's WebAssign is busy. Plus,
Yeah, it's been slow for me today too.
oh, so it wants the difference between these two numbers, which I wouldn't have known unless I'd done this.
0.01. Okay.
Yeah. Now the average cost function is the cost function divided by x. So it's 100 divided by x plus 45, because 45x divided by x is 45 minus 0.01x. So you're just dividing each of these by 100. And
Okay.
then C bar of 100 means to put 100 in for x.
Okay. $47.
47, okay. And the average cost of producing the first 100 teddy bears is $47 per teddy bear.
Okay. Oh.
You put in 100, so it's 1. Oh, it's minus, so it's 45. 45. Sorry for not paying attention there.
Also, really quick, do you, my roommate from last year, she's in Calc 2.
Yes, I can help with Calc 2.
And I just told her she's like has a final and she's worried. So
you provided me a referral to someone who was extremely difficult to deal with, and I was very unpleasant to her. And I never said anything to you because I really appreciate you, but she was. I kind of get to a point where it had nothing to do with you, but I appreciate the referrals, but I also don't just allow people to do whatever they want and complain, whatever. Yeah. And so I apologize for if anything you had to deal with anything for that.
Yeah, I know so I shouldn't have referred you because I don't think she like wanted a tutor for the right reasons.
Yeah, she
and
didn't.
like
she didn't.
Also, I think she didn't understand that. I think she thought that like I should have been more fair to her because I think she thought that you were like a student. Because she was like, this kid is, I was like, he's not a kid. Like, he's an adult.
It's okay. It's okay. Like, I deal with people like that all the time. And
I know, I felt really bad. I was like, gonna check too, but
it's okay.
But yeah, no, my roommate, she knows. She like when I met with you last year, like she was, she was
okay.
there.
Great.
And then and she's a great student. She's in Barrett too.
Yeah, I'm helping a lot of people with Calc 2 right now. So just appreciate the referrals.
Okay, yeah, that was me.
Okay, so we're dy dx here. So this is okay.
Yeah,
so 33 looks really good.
I need to be outside of the parentheses. Is that
this one is fine? 9x to the 8th square root of x. It does say to simplify your answer.
Oh, okay, that's probably why.
So that could possibly be why. You got it wrong. Or sorry to say that. That's probably why it wasn't marked as correct.
Okay.
I don't know. Um, I'm gonna say it's just that. Do you want me to simplify it?
Yeah. Can you? How do you do that?
Okay.
This
Let
the
me.
0.5x.
Yeah. Let me. I'm gonna switch screens. If I can do that here. New share. Okay. So the let me. I'm just gonna rewrite it for my own sake here. X to the ninth. Um, square root of x. Oh, I see. Um, the mistake here is that you're supposed to actually simplify this from the beginning. These have the same base, so you add the
Oh.
exponents. So
Oh.
it's 18 over 2 plus 1 half. So it's x to the 19 over 2.
Mm-hmm.
And then when you take the derivative, it's 19 over 2 x to the 17 over 2.
Oh.
So you were trying to apply the product rule, which actually does end up producing exactly what we just had here. It's just that that's not what they wanted. Um,
Okay.
so I'm going to submit that and see if that works. Then I'll reshare that screen again if needed. Yeah. Um, now you're viewing this though, right?
Mm-hmm.
Okay.
Oh yeah. Let me look at it.
So 34. So 34 is let me just look at it and with you. Okay. Bottom times the derivative of the top, 10x. Okay, so this should be minus 9 minus the top times the derivative of the bottom over the bottom. Now, so there's just an error in
Oh,
the
it's that.
subtraction symbol. And as you know, that could be the entire missed
Yeah.
point total for it. Okay. Should we go through 35?
Yeah. I just didn't even start it because I was. I don't know. Okay.
Okay, so the derivative is here. It's the bottom times the derivative of the top. Derivative of the top is 0 minus the top times the derivative of the bottom. Okay, which is 1 minus 3600 over x squared all over the bottom squared. Okay. So it's real messy because that's actually not the right way to do it. But I was just trying to emphasize the quotient rule again. Hopefully it'll take that. It doesn't say to simplify. But then you're just putting in these numbers into that equation.
Oh, okay.
Um, it looks more difficult than it really is. Okay, so this first thing is 0, so you don't have to deal with that. Um, so you're just putting 30 in for x, and then I think you're supposed to figure out which is the most fuel efficient of the three. But you're just putting that number in. Do you want us to do that?
I'll just do the first one and see if I did it right.
Okay.
Um.
Okay. Let me get my calculator out as well to compare that to.
Um. Is it normal if it's a decimal?
Yeah, it's supposed to be 4 decimal places.
0.6122.
That doesn't seem right.
Okay.
So because it's miles per gallon. Although maybe it is. Give me it one more time. It's 0.6.
Oh. I just cleared it. I think
Okay.
it's 0.6422. I think, but
I want to say that's right because it's miles per gallon per miles per hour, so it probably is reasonable. Come on, didn't like that.
Okay. Well, let me
X
just,
equals.
I'll do it one more time. So the numerator is 9,000. I got.
Yeah, so I end up getting minus 0.4 when I do it all. Probably just parentheses.
Oh yeah. So that divided by 0.4. Yeah. Oh, negative. Oh yeah. Okay, that's fine.
Okay, so that's the rest of that. Wow.
I got. It might be positive.
Okay. Oh, yeah, there's a negative. I didn't include that negative. Okay. I don't suggest we spend any more time on this
Yeah. Yeah.
question.
Okay.
Okay, so
These I had no idea what to do on the test. Like I honestly might have left it blank
okay,
when I failed
okay.
it.
The yeah, let me snip this into the workspace and then switch my. So these when you take the derivative, you have to add in an x prime or a y prime, depending on the problem here. So let me share my workspace again.
I just don't know what they're giving you. Like, why are they giving you all these numbers?
Yeah, so let me try to simplify this. They're telling you that y equals the square root of x plus 1 over the square root of x. Okay.
Mm-hmm.
They're telling you that x equals 4, and they're telling you that x prime equals -8.
Okay.
Like that's not important, but that number is.
Okay.
So you're supposed to take the derivative of this thing, y prime. Y prime is 1 over 2 square root of x. This is really x to the minus 1/2. So it's minus 1/2 x to the minus 3/2. But here's the thing that's a little bit extra. Whenever you take a derivative with x, there's an x prime here and there's an x prime here.
Can you do the square root of x as x to the 1/2 instead?
Yes. So let me restart here. So it's x to the 1/2 plus x to the minus 1/2. So y prime is 1/2 x to the minus 1/2 minus 1/2 x to the minus 3/2.
Okay.
And then again, like there's an x prime here and an x prime here.
Okay.
So now you have to put these numbers in for x. You know that x is 4 and x prime is -8. So it's 1/2 4 to the minus 1/2 minus 1/2 4 to the minus 3/2. And I'm just going to factor out the x prime, so you can multiply the whole thing by minus 8. So you end up getting minus 3/2 when you do all this.
Is that's negative 1.5?
Yes. Yeah. Yeah.
For some reason I didn't get a negative, but I'm trying to see why.
X prime is -8.
Oh, okay, that's fine.
Yeah.
Okay.
And that is correct. So let me go back to.
I want to like write down ones that I want to like that's one that I'd probably want to like go for like practice again. You know what I mean?
Mm-hmm.
Like what number was that?
39.
Okay. And then I'll probably just I want to go over the one with all those like the teddy bear I don't know what number that was, but I'll figure it out. I'll just write down teddy bear. Okay.
Okay, so do we need to go through 40?
Yeah.
Okay. So the derivative of natural log is always 1 over the inside function, which is there. Hopefully you see that on the screen. And then you multiply. Why is my screen frozen? I'm so
Times
sorry.
time.
Yeah, times the derivative of the inside functions. So the derivative of the inside function is 2x.
Okay.
That's it. I mean, there's
Okay.
there's nothing else to do
Yeah,
there.
I forgot that rule.
Okay, so the derivative of this is okay. So you kind of you got a good start here. The derivative of the exponent is 2x minus 1,
Oh.
but you also have to multiply by the natural log of the base.
Oh.
So that's a little. It's itself times the derivative of the exponent times natural log of the base.
Okay.
Okay. Okay, so this one, the only mistake is that it's 1 over 7x plus 1
Oh.
and 1 over 8x minus 2, and then you correctly multiplied by the derivative of the top and the bottom.
Okay. So if I see one like that, that's just kind of what you just remember.
It's you broke this apart as natural log 7x plus 1 plus no, minus natural log 8x minus 2. So the derivative is 1 over 7x plus 1. That's what you got here on the left, times the
Yeah.
derivative of the
Oh,
bottom, which is 7,
okay.
and so on. If you want me to work these out, I will. I don't mean to not do that. I just didn't.
No, that's fine.
All right. I need to pause for just 30 seconds. I'll be right back.
Okay.
All right, I'm back.
Okay.
Do we need to go through this one? 43.
Yes.
Okay. So this is a quotient rule problem. So it's the bottom times the derivative of the top. The derivative of the top is 0 minus the top times the derivative of the bottom. So the derivative of e to the x is e to the x, but the derivative of e to the minus x is minus e to the minus x because it's itself times the derivative of the inside part. The inside part is the -1. That's why it's there. Over the bottom squared.
Okay. So
So
it
it's
would
pure
be
quotient rule. Sorry, go ahead.
e to the x minus e to the negative x times 0
Yep.
minus e to the x plus e to the negative x times 9 over that squared.
Yes.
Okay. Got it.
Okay, so should we go through 46?
Mhm.
Okay, I'm gonna snip that one into my other workspace and then we'll work through it.
Yeah, because the second half is probably where I need the most help, but these ones I was obviously struggling on too.
Okay, so the derivative here of xy cubed is a product rule. So it's the first times the derivative of y cubed. The derivative of y cubed is 3y squared, but there's a y prime.
Yeah.
Plus the derivative of the first, which is x, or just 1, to keep the second y cubed. Minus, so the derivative of y is 1, but the derivative of y is y prime, equals the derivative of x, which is 1.
Okay.
So I'll clean this up a little bit. It's 3xy squared y prime plus y cubed minus y prime equals 1.
Mm-hmm.
So you get the y primes on the same side. We're going to move the y cubed over. So this is 1 minus y cubed, which is what you got up there. That's good. And then, oh, you're just missing an x there because it ends up being y prime times 3xy squared minus 1. So y prime equals 1 minus y cubed over 3xy squared minus 1.
Oh, okay, got it. Okay.
Okay. There's one right below it. Do you want us to do that together also?
Can I just try it out really fast?
Sure.
What number is it?
47.
Okay. So would it be e to the y prime? Like, is that the derivative of e to the y?
Yes.
And would the y prime be like still in the exponent?
No, it's down at the base level, I guess, or it's next to the e to the y.
Um, yeah, I don't know. I don't know if this is right. Negative e to the y minus e to the xy over e to the yx minus e to the x.
I missed some of that, but I think I've got it here.
Okay.
Yeah, it's this. This is correct. Y e to the x minus e to the y over x e to the y minus e to the x. The bottom sounded right.
X. Okay, well, mine are all in. Okay.
So let's go through
Yeah.
the derivative because that's really the key step here.
Yeah.
So the function is x e to the y minus y e to the x equals 3. Okay, so the first one here, product rule. We're going to keep the first, derivative of the second. So it's x e to the y prime plus derivative of the first, which is 1. So we don't have to write that. Keep the second, e to the y minus. Now, we know this is product rule, so I'm going to put it in parentheses here. It's keep the first, derivative of the second, plus the derivative of the first, which is y prime, keep the second. So if you didn't distribute your negative, that could potentially have led to this problem.
Okay. Yeah, that's probably why. Also with is there like, obviously it doesn't matter, but when I did it, I do like y e to the x, but is it easier to do like e to
It's
the
what
x y?
you should do it the way you're most comfortable at this point.
Mhm.
That
So
part isn't going to matter. Okay, let me
yeah,
let me
no,
get
that makes sense.
let me get back to sharing that, and we can keep going through this list here. Um,
Okay.
these all look good. Um,
That one I
you
either got 27 or 36 and it both was wrong, but I was confused why.
Do you want me to go through that one then?
Yeah.
I'm sorry, was that a yes?
Yes.
Okay, snip that over. All right, so the rectangular vegetable patch. The fencing for the east and the west sides is $4. North and south sides is $2, and you have a budget of 144. So we have we're going to call this X and this Y. So the cost function is 4X plus 4X plus 2Y plus 2Y. Is that okay?
Mhm.
And that has to equal 144. So we get 8X plus 4Y has to equal 144. We're going to end up solving this for Y. So Y equals 144 minus 8X over 4. And that simplifies to 36 minus 2X. Then we know that the area is X times Y. So it's X times 36 minus 2X, which is 36X minus 2X squared. So we're going to take the derivative. The derivative of this is 36 minus 4X. So you're going to set X equal to 9, and that's where it's maximized. So 9 is your east and west sides.
Oh,
And then Y
you
is the
set 9 because it
36.
set it equal to 0.
Yes, you take the derivative and set it equals 0. So your other answer just needed to be 9.
Oh, okay. I think my problem was that I just did 2x plus 4y. I didn't do 8x plus 6, whatever, plus 4. I didn't do 8x plus 4y.
Okay.
That's probably why.
You see, you'll see it now in there. So
Okay.
53 is the one we did the other day, like that. So do we need to do 52?
Yeah.
Okay. I don't understand these open top box problems.
I
Boxes
think
with
what it is like
subtops.
it's like 16 minus 2x and 13 minus x.
Oh, I'm sorry. What I mean is like I never get a box that's open. I
Oh,
always
yeah.
always get a lid. um, yeah. So what you're doing is you're taking this is 16 and this is 13 if you want. You're taking out squares out of the corner.
It's weird because I did these in high school and I remember I was like a pro at them. And then now I'm like, I always get so lost. I don't know why.
So
Like I
this
know how to
is
set it up and then I don't know where to go from there.
well, this is the volume. So like what you're doing is the graph of this looks like this.
Oh, wait. I think I'm not
Oops,
seeing
I'm sorry. I'm sorry. That's the one limitation of this is I forget that. Okay, you should see the screen with the 16 and the 13, the volume function.
Oh, and you just graph it?
Well, you can. The calculus is multiplying this and setting the derivative equal to 0, but this is the volume. So
Yeah.
it's just whatever the y value is here.
Oh. So that's probably what I think what we did in high school is literally just graphed
Yes,
it and then got the
yes,
volume.
exactly.
And then but for this, like the dimensions and stuff, I guess you can still use a graphing calculator, but I remember I multiplied it out today and stuff and did the derivative and then equal to 0. And then I was using like the quadratic equation and just got really messy.
Yeah, you don't have to do
Um,
any of that. I mean, you
okay.
just have to. I mean, you just literally just
And then
graph it.
how would you do with your zeros, like with the 0 that's the makes the most sense, that's like your x value, right?
The zero over here.
Yeah.
Well, we know that it can't fold in on itself. So
Right.
x we know it's 6.5 is this one, and this one's 8.
Okay. And then you would use, which one would you know to use?
You're not using the zeros. You're using the y value here.
But like if they ask for the dimensions.
It's the x value wherever it is. Like whatever the x
Oh,
value is
oh,
here,
okay.
you're at a peak. So it's whatever
Right.
it is there.
Okay, that makes a lot of sense. Because I've always been like, why did I know how to do these in high school? And it's because I just graphed
You
it. But
did.
every time I
You did.
went to the math tutoring center, they would try and like make the whole mess of like doing the algebra, and it would just make me more confused.
You're supposed to do it that way, but WebAssign doesn't care how you do it.
Right.
So you should
Right.
do it the way that gets you the right answer
Mhm.
for the exam. And I hope you can get it here. And we can do 54, but I'll just point out again that this is like
Yeah.
exactly like the other ones we did. And you didn't think you're going to get it, but we can do it if you'd like.
No, I probably would get it, but it's okay
Okay.
because I can just look at my notes or something.
Okay. 55, do we need to go through? It's new start of a new section.
Yes.
Okay, so 55 is the second derivative of this. So the second derivative,
Oh.
the first derivative is t to the minus 1/2 plus 4t. Okay, so the derivative of that is minus 1/4 t times to the minus 3/2. I mean, I would not encourage you to do this the way I'm doing, but it's good enough. Yeah, and then the derivative is 4.
Okay.
And then this answer is putting
You just
4
plug
into
in
this.
4.
Yeah.
Okay.
So why don't you do that? I'll submit this, and then you can give me that number. Oh my goodness. Oh, I didn't put a negative out front.
Oh. $3.97.
Should be like a perfect number because you're putting 4 in, and no, I'm wrong. I'm wrong. It's not going to be a nice number. It's going to be the 2 root 2. That's it, really? Oh, 4 squared 8th minus 1 over 32. It should be a nice number. Let me calculate it as well. $127 over 32. It's not a nice number, but it is a fraction.
Okay, so that's still okay.
Unbelievable. Okay, 56 is to graph this. I don't think you need any help with that. I already did all these. That's
the next one I was confused. For some reason, I couldn't figure out like how to get all that stuff. I was like tracing the intercepts on the graph, and like for some reason it, I don't know.
Well, I mean, I have to graph this. They should be nice considering these numbers up here.
Oh, I know why. It's because I entered it wrong in my calculator.
Okay. That will do it. Do we need to go through that?
No, but can you just scroll down? Yeah, those, okay. Extrema, wouldn't it be?
There's no minimum or maximum.
Oh.
Because
Those are relative.
It goes forever, up forever and down forever.
So those are relative.
Yeah, it does have relative mins and maxes, but I'm guessing this is DNE for both.
Okay, that makes sense.
The inflection point is the second derivative, setting it equal to 0.
Oh,
So it's 6x squared, 12x plus 6, so it's at -2, is there's an inflection point.
okay.
Yeah, so at -2, comma, and then you have to put that back into the
So it's
original
like,
function,
okay.
whatever that is. Do you want me to find that or not?
No, I can do that a different
Okay.
time.
Okay. And then the end behavior,
Yeah, I can figure that out.
you can figure that out. Great. Okay. 59 was on your most recent exam that we worked on together.
Yeah, these are all where it gets rocky.
Okay. So I'm going to just start snipping these in. We'll work on these.
Okay.
Okay. The area of a circular sunspot is growing at a rate of, so A prime is 1300. And I know that because of the units. The area is pi r squared. I know that because it's a circle. Okay. And it wants to know how fast the radius is growing. That's r prime. When it equals when the radius is 4,000. So to do this, you have to take a derivative of this function over here. A prime equals 2 pi r prime. And it wants r prime, which means you have to solve for r prime in the equation over here. So it's a prime divided by 2 pi r. And you have these numbers. So you have that a prime is 1300. You have 2 pi and the radius is 4,000. So you just, whatever that number is.
Okay.
I will get it for you, but that is, it's pretty small. 0.052.
Yeah.
Okay. Now it says B is a totally different question. The stuff from A doesn't apply, but the stuff from here does apply. So it's almost good to just kind of restart it, which is what I'll do here. We're going to ignore this. Okay. So when the sunspot has an area of 490,000, this is the part that's really unclear, is you can calculate the radius because you know that the area is pi r squared. So you know that the radius is the area divided by pi square root of that. So it's the square root of 490,000 over pi. But that's not what it's asking for, but you're going to need that. It's again asking how fast is the radius growing. It's asking for r prime. R prime comes from the derivative of this function. This derivative is a prime equals 2 pi r prime. So when you solve for r prime again, you need a prime over 2 pi r. A prime is 1300 from the previous problem over 2 pi. And see, if you didn't know the radius, that's where you would get stuck. You would say, well, what's the radius? That's why this information is given.
Okay.
So the radius is the square root of 490,000 over pi. And they want you to round that to 4 decimal places. Okay, 1300 divided by. So this one is
0.5239.
0.5239.
Yeah.
60 was not on your test. 62 was. But I'm sorry, you can't see my screen. Okay, so like this is just my opinion, but 60 was on your test, I think, but like 61 wasn't. So I wouldn't do 61.
Okay.
But that's just me. I'll snip 60 in.
Okay.
And we can work through that. Okay.
I think we'll be able to go through the rest tomorrow.
Not all 40 of them, no.
Okay.
I would do as much as you can.
Okay. I'll try to like follow because these are the ones that I just like
I mean,
Don't.
I can give you the answers to all of them, but it wouldn't be, it
I
would be
think
nonverbal.
I'll just try and like watch videos tomorrow and like do as much before we meet.
Okay. So the derivative of this is 3, because that 3 out in front, times 4/3
Oh wait, I
pi
can't hear
r. Oh, I'm sorry.
screen.
This format I hate sometimes. It's the one limitation here. Okay. Of this. Can you see in my screen now?
Yeah.
With 4. Okay. So I was saying that you bring the 3 down, you keep this r squared, that's power rule, times r prime. So here's what you need to figure out how fast the radius is growing. You're trying to find r prime. You need to know v prime, which is right here, it's 6. And you need to know the radius, which is 1. So the r prime here is v prime over, those cancel, so it's 4 pi r squared. So this is 6 over 4 pi times 1 squared. And it wants you to round your answer to 2 decimal places, so you can try that. So 6 over 4 over pi. So 0.48. Let's just look at this together, the rest of the WebAssign here. Starting at 62, there were a ton of questions on your last midterm. Well, both of those on your midterm were there. I would look at those, try to do those. And then I don't recall you having these on there, but you probably did.
Yeah, I think you did.
I think you did. So these are good to look at again. I know you won't be able to do them all, but you certainly
I
can
mean, I have a lot
try.
of resources, so I'll just try.
Like 76 was not on your last exam.
Yeah,
Just so
Remon. I think we had like one Remon, some like, if any.
yeah. And then the most recent homeworks, we did integration by parts on those. There's a lot there with those, but and then these are all good. So I guess I only saw one question out of this group that you like. You did not have a problem like 91, and even on your homework, as far as I recall.
I
92,
remember,
you
yeah, I
go ahead.
remember doing one like like the 5 unit. Remember when we did that?
Yeah, we did that, but like 91, no, 92, yes.
Yeah.
Uh, these were all on there. Yeah.
Yeah.
Okay, so that ends the lesson for today. I'll send you over these notes, and thanks again for scheduling. I'll see you
Yeah.
tomorrow night.
All right. See you tomorrow.
Okay, bye now.
Bye.